Folks, Matthew Lanigan here with BayWa RE. I see people are still logging in, so just give it about 2 more minutes and we'll be ready to go. Thanks so much. Hi folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here at BayWa. Just a couple of housekeeping notes before we get started here. There is a chat box, so we will try to answer questions in real time. So if you just want to put those down in the bottom right corner, we'll be happy to answer them. This will be recorded. You can always ask your sales reps for pre-release of the recording. Otherwise, it'll come out in our September newsletter. Continuing education is very important to BayWa for our staff as well as our customers. So once again, thank you so much for joining. And without further ado, I would like to introduce Jason Hanna, the Field Sales Engineer with IMO.
Okay, thank you for that, Matt. Can everybody see my screen okay? Should be the introductory screen.
We can see it.
Okay, perfect. Well, thank you, Matt, and thank you everyone for attending this presentation. As Matt said, my name is Jason Hanna. I'm the Field Sales and Engineering Manager for IMO Precision Controls and the IMO Automation here for North America. And our presentation today is on our non-fusible AC and DC disconnects and correlating with energy storage systems. Our agenda today will consist of giving you I'm just going to give you a brief introduction about us, about IMO, and our brief history into the market. Going into our 69 series AC disconnect, we'll be highlighting the features and the mounting options, and of course touching on the ratings according to UL. From there, we'll get into the sort of the crux of this presentation, which is our SI true switching DC disconnects. These will highlight the features and mounting options as well as showing you the disconnect switching differences, why we so highly favored this form of disconnection over traditional means. And then we round it off with the quality and safe, reliable DC switching value-added proposal. We then go into 3 examples of installations that comply to the UL 9540 standard. In doing so, we need to just touch on the CEC codes, more predominantly 060, 904, and then 914. We'll show an installation with AC, with our AC disconnect and an installation, as well as battery backup and energy storage systems, as well as a disconnect and a ground mount installation. From there, we'll get into just one slide about the IMO products, contact information, and then we can open it up for question and answers. So first, a little bit about us. IMO Automation is a division of IMO Precision Controls, and it was established in 2016 to support the US and Canadian markets. IMO Precision Controls is a British-based manufacturer of high-quality electrical control, automation, and switching products for the renewable energy, and it has served these global markets for over 40 years. IMO is a collection of professional sales and manufacturing engineers dedicated to a high level of customer service. And our history begins, bear with me, our history begins with our founder who in 1962 developed a relay manufacturer called Key Switch, which soon became IMO Precision Controls in 1970. Innovative products such as PCB terminals and high-speed BT-type signal relays led IMO to manufacture industrial controls with the onset of the Jaguar, a compact AC motor drive that led the industry with a unique 5-year warranty. The success of the Jaguar fueled the development of control panel and automation products such as motor control, contactors, disconnects, and DIN terminals, all the way over to PLCs and HMIs. Over the years, the brand name has been grown to be a recognized brand of industrial controls and automation solutions. However, in the last 10 years, while supporting these other product families, IMO started engineering and launching product strategies in response to a rapidly growing renewable energy sector. And it began with the industry's first true switching DC disconnect, which guarantees safe and reliable DC switching within a PV system. A few years later, we had another industry first, which was the development of a simple out-of-the-box solar tracking controller called the SolarQ. This microprocessor and GPS-based controller was engineered specifically to optimize clients' yields in their solar harvesting, as well as to provide a reliable control and monitoring of a 1 or 2 access array. With the onset of NEC 2017 in the States, IMO engineered the first module-level rapid shutdown system that doesn't use power line communications, adamantly called the Fire Raptor. And it disconnects the DC current as closest to the source in under 1 second and can be installed into a new or existing PV array. So today, IMO Precision Controls continues to develop new product strategies to meet the needs of the industry and providing high quality, competitive, and value-added solutions. So with that, I'd like to get into our AC disconnect line, starting out with our product family and features. So the main features of our AC disconnects, we have on-load disconnects from 10 amps to 125 amps. These are available in a 3, 4, 6, and 8 pole version. We do have multiple mounting options available, and we generally stock these in the standard red handle with yellow cover for easy identification, but we do have optional black handle and gray enclosure options. The handle has 3 padlock positions, lockable in the off position, and these enclosed versions are IP66 and NEMA 4X rated. We do have a variety of accessories available, solid neutral blocks, switching neutral blocks to auxiliaries and other type of bolt-on type accessories. These are suitable for motor disconnection, and they are CUL approved, and these are a non-fusible version only. The multiple options that we have for mounting include a single hole mount where a contractor can, if they're doing their own panel, can knock out a 22.5 millimeter keyhole and just install the handle through it, and it'll just bolt to the back. We have a DIN rail mounted version, as well as a traditional back panel mounted extension and door handle mechanism, and panel mounted version, and then probably more relevant to this presentation, the enclosed version. Our UL approvals for these are, like I said, on-load rated, so we are good up to 600 volts AC and up to 125 amps. Our operating temperature ranges between minus 40 to plus 40, and our storage from minus 50 to plus 90. Getting into our isolation, our SI true switching DC isolators, we'll go over the features really quick. The disconnect itself is a market leading design. We have incorporated a patented safe lock off feature. These are available in a 2, 4, 6, and 8 pole version. The maximum rated current on these is only 85 amps at 600 volts DC or 70 amps at 1000 volts DC under CUL. We do have a range of mounting options. We have a guaranteed arc suppression, which is about 3 milliseconds typical. These have an operator independent switching mechanism, knife edge contacts. The enclosed versions are rated at IP66 and NEMA 4X. And these are CUL approved under UL 508. And for those who are in the US, we are rated as a UL 508I or isolation status for these disconnects. And these are also non-fused only. Like the AC disconnects, we offer pretty much the same type of mounting installations. And again, much the same flavor of mounting provisions. But for this application, we'll probably focus more on the NEMA 4X disconnect, the enclosed version. So what's the switching difference? With traditional AC disconnect technology switching DC current, there's going to be a few issues. And the main issue is going to be the speed of switching that is still controlled by the operator. So a slow switching of the contacts will lead to an increase in arcing time across those contacts. Over time, those contacts will be deteriorating, those contact surfaces, and eventually leading to a failure or fire. So AC disconnects that are traditionally used for DC switching will tend to be oversized to compensate for the arcing, along with a large jumper arrangement across the poles, and this is meant to disperse the arcing. So if you look on the screen, I'll just pop a quick video here. This is a traditional contact type disconnect. You'll see that the operator is actually influencing the speed of disconnection. In that case, the arcing will be allowed to remain as long as the arc is close. This is our knife edge switch, and you'll see that instantaneously we try to slow it, but we can't. It's a 5 millisecond switching speed. Because of the architecture inside, which I'll get into, makes it very unique. It limits the amount of arcing, little time for the arcing to occur. And that's because with the SI disconnect, it is engineered specifically for DC current. So it comprises of a high tension torsion spring with trigger clutch. So when an operator switches the disconnect into the on or off position, you're going to feel a bit of resistance. That's because there's a torsion spring that's going to be charging as it's moving. So when it gets to the release ribs, which you can see in the diagram below, there's little notches that as soon as it gets to that point, it triggers and releases the energy contained in the spring, and the spring basically takes over the switching action. Combined with this, we also have a very unique disconnect architecture. So it comprises of arc extinguishing plates, and these disconnect the power on the side of the contacts versus the front, where there's more surface energy. So on the sides, there's less surface area, and less surface area means less arcing. Combine that with arc extinguishing ribs that help to starve the arc, the oxygen in the arc chute. And because of this, if we can keep the disconnect operating cooler, the arc is contained and controlled. Because these aren't AC rated, well, they do have an AC rating, but they're predominantly DC. We don't need to oversize the disconnect itself. So the size of the disconnect remains smaller. It can be put into a lot of applications where normally you'd find other manufacturers with quite a large enclosed disconnect. We can actually keep ours very, very small. And quality, safe, reliable DC switching. One thing we do offer is a unique 5-year manufacturer's warranty from us. We actually have documented over 5 million installations worldwide with no reported failures. We've engineered these for high reliability and, of course, longevity. And, of course, with the Safe Lock, very unique to IMO. And this ensures that the disconnect itself cannot be locked off if one or more contacts unexpectedly weld. That's it for the technical piece, and we'll get into the installation portion. But before I go any further, I was just wondering if there's any questions or any feedback.
There's a few here, Jason. So Peter asks, are we allowed to use non-fused AC disconnect in Ontario market for rooftop ARC PV? Please confirm.
Well, if it follows the line of the code, DC disconnection is to disconnect your battery sources within 9 meters of the system. So if you're talking about rapid shutdown, I'm not sure if understanding this correctly, but if you're talking about rapid shutdown, we actually have a separate product for that if you're disconnecting your PV arrays from the roof or what have you.
I believe that's okay. Peter, we can round back with you on that. We have Kuno asking, I really like the IMO DC Isolator switches. When will they be CSA or CUL approved? I have a hard time with Nova Scotia Power inspectors. The switch is CUL, but the enclosure is not.
Yes, actually, we had a change there not too long ago. We had our disconnects approved for UL first because there was no specifications for DC in Canada for a while. So as soon as it came into play, we applied and of course we got it. However, in doing so, we still had old stock that we thought we cleaned up and put new recertification stickers on and so forth. So some did go through, and I remember there was a customer in Nova Scotia that we just replaced disconnects with the brand new ones. They were the same disconnects, but they had the new logos on it. In short, you shouldn't be seeing any of our disconnects without a CUL US sticker on it. Even the enclosed versions as well too. And if there is, you definitely let us know and we'll get that changed up. But yeah, it was just, there was some stock that made it through during the certification process.
And Peter had a follow-up for the AC disconnect located outside, that must be in 1 meter of the head. No, we'll round back with you on that one, Peter. I think we're good for now.
Okay, that's it? No more questions? Okay, perfect. Okay, well, this next section deals with the AC and DC disconnects within an installation, and we're going to show relevance to the UL 9540 and quoting some of the CEC codes as we mentioned. The AC disconnects, where we generally will find these, will be providing a convenient disconnection of an energy storage or inverter system going back into the breaker panel. Essentially, the AC disconnect is a high visible and generally installed closest to the meter base, and just provides that lock-off provision should you want to disconnect one of your services. Where the main part of this, the code relies on, is the SI True DC disconnects. We actually go into UL 9540, and in doing so, we just need to touch on a few codes that are applicable to it. So applicable codes to our DC switching isolators will be 64060, which describes where a disconnect is used and the means of disconnection. 64904, which defines the voltage restrictions within the energy storage systems. And finally, 64914, which is very similar to 060, but it just makes it more specific for the energy storing system. Again, I'm not going to go heavily deep in depth into the codes, just whatever's relevant to the DC disconnects. So to start off, just going to move my screen here. We first look at the code dealing with where our DC disconnects are to be used. So under section 1, our disconnect would be used as a disconnect for underground conductors that supply power from a renewable energy system as well as batteries. We see that the disconnect is required to be within 9 meters of the line of sight of the equipment. Section 4 deals with exactly what types of equipment are to be disconnected, and this includes batteries, inverters, and charge controllers. There we go. Going deeper into this piece, the code, we examine what is required for disconnection. So we started with the ability to wire the disconnect from both sides. In our solar products catalog on page 14, we do illustrate wiring and jumper configurations available for each configuration. These configurations will allow you to wire the string and load into the top or bottom terminals of the disconnect, as well as having the ability to jumper and configure the disconnect to the application. Next in the code, it states the disconnect needs to have a visual indicator of the switch's status. Our AC and DC disconnects do have a window built into the rotary handle that indicates what position the switch disconnect is in. And in the case of the SI DC disconnect, we have a third position that are safe, which is our safe lock provision, which I'll discuss a little bit later in this presentation. Next, the disconnect must be able to be locked in the open and off position. As stated before, our AC and DC disconnects have up to 3 padlock provisions when in the off position. However, note that the DC disconnects will be locked only in the safe lock position of the switch. Moving to the next part, the code states that the disconnect must be able to be opened at a rated load. Again, in our catalog on page 20 of the solar products catalog, we list the approved rated amperages for each of the disconnects. These are all on load amperage values, and there's no derating required. However, if you are having to put the 25% safety factor on, it does not include that. That is something you would have to factor into your installation. This last section indicates that the disconnect should be capable of being closed at the event of a fault in the system. We know with the high-speed knife technology that we have talked about that these disconnects will open and close circuits efficiently should there be a fault in the system. However, I think one of the SI disconnect features that I need to highlight is more relevant to do with the safe lock function that we've talked about, which I'll get to in the next few slides. Under 64904, our disconnects are meant to be used for section 2 within an energy storage system. This is due in part because of the potential voltage and amperage differences between a field assembled energy storage system and a self-contained energy storage system, which I'll briefly talk about in the next few slides. And lastly, I'm not going to go through this again, but 64914 is very similar to 64060, and it basically summarizes the means for disconnection specifically within an energy storage system and echoes the same disconnect specifications we spoke about earlier. As we discussed previously, the IMO SI true switching DC disconnects conform to all of these standards for safe and reliable DC current disconnection within an energy storage system. So just reviewing really quickly, the two types that we're talking about is one is going to be the battery backup system. These are the systems that are assembled on site. Battery cells are connected together, and generally speaking, there's a low voltage but high amperage configuration. These types of installations may exceed the ratings of our disconnects. In some cases, typically a 400 amp switch has been used. However, in an energy storage, self-contained energy storage system, this is where our disconnects would reside. So they're very popular, as you know, for small residential and commercial applications. The battery cells are supplied and connected internally. Generally, there's more of a high voltage and lower amperage, more in the specifications of our disconnects. An example of installation, here's one here that the team at BayWa have provided some great graphics on. In this case, we're using an auto transfer switch, whether you're using a SolarEdge BUI or a backup interface or an interface smart switch. It essentially interconnects the various systems and diverts power to within the system and also provides monitoring and controlling the system. So where we would have our DC disconnect would be between the battery system from the interface from the battery system into the BUI, and you can also have the AC disconnect depending where it is on the inverter side as well too. Now also note that because that we're just showing a diagram of this particular installation, there's going to be other variations of this same installation, and it's really subject to the manufacturer's design. For DC disconnects for ground-mounted systems, the purpose for our DC isolators will be a means to localize disconnection of DC power from a nearby array. This will provide discrete and convenient disconnection for maintenance or repair of the array, and also an AC disconnect is installed by the meter base, again, to isolate the inverter from the panel and provide a very convenient way of disconnecting. That kind of brings us to our conclusion, just reviewing of all the installation and the code compliance and so on. A little bit about other products available from our product line include a variety of control panel products and automation products, everything from pilot devices down to automation and control. Here's our contact information for our team at BayWa for all of our sales and distribution. There's a good stocking array out there. If there's any questions or any tech support you require on the disconnects, definitely give us a call and we can help you out. Otherwise, that concludes my presentation. I can definitely open up the floor for questions.
Yeah, we have another question here, Jason, from Andrew. My primary question is whether the IMO AC disconnect is able to replace a component such as the CHU362RB in terms of satisfying the non-fused disconnect requirement of the Ontario Electrical Code as it applies to disconnecting means for microinverter systems?
Well, I'd have to look that up, but a microinverter, if you have 240 volts coming across, plus neutral, I guess you wouldn't have the neutral. Our disconnects are fully rated up to 600 volts and are rated for lower voltages like 240 and so on. As far as the compliancy of that in Ontario, I would have to look that up, but if the application calls for a non-fused disconnect for a PV panel with microinverter, then yeah, our disconnect technically will satisfy those means. But I would like to research that code a little bit further as well too.
Okay, we have the question on file here, Andrew, and we'll be sure to follow up with you.
Yeah, thank you for that.
Do we have any more questions out there? Okay, so I'm not seeing anything come through. If you do have any follow-up questions, please reach out to your outside sales reps or the folks at IMO. Once again, really appreciate everybody taking the time to be with us here today. There is additional information on our web shop for those of you who haven't experienced it yet. You can go punch the part number in, the specs, the warranty, the install manual. The stock levels are all there, so I would encourage you all to go there and check that out. This has been recorded, so we will share it once again during our next news mailer. And thank you again, everybody, for attending, and thanks, Jason, for taking the time to educate us on the product a bit more.
Hey, my pleasure. Thank you to everybody for your time, for sure.
Take care, everyone. Oh, there's one more.
Okay.
Any plans for low voltage, high current DC applications for battery banks? From John.
That is something we are presently tabling. Currently, we have contactors that are meant for high voltage and high amperage ratings. We're looking at re-engineering in the future some of those for those applications for battery storage, but at this moment, there's nothing that I can provide right now. But we are looking at that for sure.
Okay, great. Thanks again, everybody. Hope you're all well and take care out there.
All right, thanks again.